I just want to pick up a little bit on number 26 that we were talking about with the trading card example, where we figured out that there was an 8 out of 90 chance buying a pack of 8 cards of getting this number one, the last card in the 90 card set, card number 90. So, 1 of 90 chance with each card, but there's 8 different cards, so 8 out of 90 chance for one pack. But then figuring out, well, what's the chances for 2-pack? The temptation is to go, well, wouldn't it be for 2-packs like, well, you'd square this, and that would be your chances for 2-packs? So to make that illusion go away, let's look at a smaller example. Let's imagine that instead of 90 cards in the set, we've got 3 cards in the set. And instead of having a pack of cards, we just have 1 card. So the first card we pull, we have let's say we want card number 3. So if we pull a card, we would have a 1/3 chance of getting our card. And using this logic that I'm going to prove is false, you'd think if we pulled 2 cards, we might have a 1/9 chance, right? And that doesn't actually work. Now, the answer we ended up coming up with over here was we used the complement. We used the complement of this thing. And so what that looked like is we said, oh, well, the chances of not getting the card are 82 out of 90. And that's what I'm going to square for 2-packs, and then 1 minus that is going to be my answer. And except we actually were using 10-packs. But so let's see how that works over in this example over here. This example. So really, my first shot, I have 1/3 chance of getting my card and a 2/3 chance of not getting my card. So if I now pull 2 cards, and I could get, and now I'm allowing for repetition, right? That's a key distinction. So if I pull 2 cards, and I'm allowing for, so my first card, I have a 1/3 chance of getting it and a 2/3 chance of not getting it. Just like over here, I had an 8/90th chance of getting it and an 82/90th chance of not getting it. So here's 1/3 chance of getting it, 2/3 chance of not getting it. So, and I'm saying here I could not just square this side. I had to square this side, figure out the complement. And so it follows the same thing here. The odds if I pull 2 cards are not 1/9, but it's going to be, what I'm going to do is I'm going to square 2/3. I'll get 4/9. So a 4/9 chance of not getting it, which means a 5/9 chance of getting it when I pull 2 cards. So why would that be? Well, let's look at this. 1/3. That means I have 3 possibilities, right? I get it, or I don't get it. I don't get it. So that's 1/3. But now I repeat the event another time over here. 1/3. So you see what happens if I just multiply. Well, 1/9 is the chance of getting that card to repeat itself. But I don't need my card to repeat itself. And meanwhile, squaring 2/3 is my chance of getting the card to not show up at all. But the 5/9 comes from the fact that these 4 are all include the card. So the question about whether I get the card, it doesn't matter if I get it twice or if I get it once. I have a 5/9 chance of getting my card and a 4/9 chance of not getting it. So the idea of repetition, the doubles is taken care of, and there are no doubles here. What I mean by doubles isn't totally clear, but I think now it makes sense that, okay, if I have a 1/3 chance of getting it once, but then I go again, a second independent event, and they're independent events, so everything's replaced, right? So yeah, my chances of getting that thing to repeat itself are 1/9. My chance of just getting the card I want, period, is 1 minus 2/3 squared. And similarly for number 26, the answer is 1 minus 82/90 to the 10th power, because you were buying 10 packs of cards. And so that is the end of our section 12.5 survey. Thanks for watching.